retrieval augmented generation hits a hard wall with long documents. You either chunk too large and drown your model in noise, or too small and lose the semantic thread. Existing fixes like LLM-guided chunking or recursive summarization are either computationally brutal or inherently lossy. Enter SPROUTRAG, a framework that replaces flat retrieval with an attention-guided hierarchical tree built entirely from a lightweight sentence-level transformer. Here's the architecture. The document is split into sentences and encoded. Instead of naively averaging attention across all transformer heads and layers, which introduces a proximity bias that collapses global structure, SPROUTRAG learns a weighted aggregation. It assigns trainable scalars to specific heads and layers, letting the model discover which attention patterns best capture semantic correlevance. Using those learned scores, it constructs a binary tree bottom-up. Every merge creates a parent node with a progressive embedding, meaning each internal node compositionally represents a larger, coherent semantic unit. At inference, there are 0 external LLM calls. The query is encoded, and a hierarchical beam search traverses the tree. It expands the active beam at each depth, retaining the most relevant nodes while collecting candidates across all levels. This lets the system pull precise facts from leaves or broader context from internal subtrees, depending on the query. The pipeline is fine-tuned end-to-end with a joint objective. A contrastive loss aligns query passage embeddings, while an attention regularizer forces co-relevant sentence pairs to share high mutual attention, directly shaping the tree's grouping logic. The results are sharp. Across scientific, legal, and open domain benchmarks, SPROUTRAG improves information efficiency by over 6% on average. It recovers multi-sentence clauses that flat retrieval fragments, all while keeping online latency under 200 milliseconds per query. SPROUTRAG proves you don't need heavy LLM filtering or lossy summarization to solve long-context retrieval. You just need to let the model's own attention structure do the organizing. The full paper and implementation are linked below.